Hello everyone, I'm Dr. Lovely for those of you that don't know me, and I'm going to present this week's lecture on probability and statistics. There are various learning objectives that we hope to achieve with this lecture and the associated activities. The first is to understand the meaning of probability of an event. We will learn how to create a histogram in Excel. We will use the histogram information to draw conclusions about a process, learn how to calculate probabilities from a normal distribution, and use probability theory to calculate the probability that a system works as designed. Please note that there's a great resource for this lesson in the textbook, chapter 19. And also, it is important to understand that these topics are usually covered in a semester-long course. You may have taken a probability and stats course in high school. Most of you are required to take a stats class in your engineering program. So we are definitely doing a condensed version of a lot of these topics. So if you get confused or lost at any point, please pause the video and go back, re-listen, and hopefully it'll make more sense to you. So probability is how likely an event will or will not happen. So we may want to know, for example, the likelihood of a hurricane hitting a city on the Gulf Coast, or the likelihood a piece of equipment will fail after it's been used for a given period of time. Civil engineers might want to know the probability a river could breach a levee, and an electrical or computer engineer may want to know the probability that their microprocessor will fail under a certain condition. There are many ways engineers use probability in daily work. So let's look at the basic equation of probability and look at a simple example. So the equation that we're going to use is P, which stands for probability, is equal to S divided by N, where S is the number of favorable outcomes and N is the number of equally likely possibilities. So what is the probability of drawing an ace from a deck of 52 playing cards? Okay, so let's look at what is the S in this equation, or in our example. So that's the number of favorable outcomes. Well, in our case, drawing an ace is the favorable outcome. And how many aces are there in a deck of 52 playing cards? Okay, there are 4. And what is our N in this example? Well, our N is the number of equally likely possibilities, which in this case, each time we collect a card or we pick a card, we have an equally likely chance of getting an ace. So we have 52 there. If we put those values into our equation, 4 divided by 52 is 0.077 or 7.7% chance of drawing an ace from a deck of 52 playing cards. The sum of the probabilities of all possible outcomes is equal to 1. Okay, so what that means is that the sum of all probabilities for drawing any given card from a deck of cards would ultimately equal 100%. You cannot have a negative probability, and you cannot have probability a total probability greater than 100%. Okay, so keep that in mind. If you ever calculate a negative or a value greater than 1 or 100%, you have done something wrong. So what are statistics? Well, they provide quantitative measures to things that behave in a random manner. Okay, they help us make rational decisions given a level of uncertainty. And let's face it, in everything that we do, there is a certain level of uncertainty. So what's the role of statistics in engineering? Statistics can help us evaluate new or alternative designs, concepts, procedures. They can help us come up with estimations. So for example, an amount to bid on a project. And they can also help us determine a degree of acceptable item-to-item variation, which is very valuable in quality control. A common way to analyze an engineering problem is to conduct an experiment. And when we conduct an experiment, we have to answer certain questions. For example, how many tests do we need? How confident are we with the results that we got? And can we estimate how often a result will lie in a specified range? So statistics can help us answer those questions. Now, when we conduct an experiment, we end up collecting data. Okay, and what can we do with the data that we collect? right? So let's say I want to collect data associated with how tall everybody is in EGR 103. Okay, so I can go out to every student in EGR 103 and I can in an Excel spreadsheet, collect how tall everybody is. So what do I do with that data? How can I make sense of it? Well, descriptive statistics are used to describe or summarize data in ways that are meaningful and useful. Okay, and one of the most effective ways to summarize data is through the mean, median, mode, and standard deviation. So the mean is another word for average, and the average is the sum of all the data points and divided by the number of data points. The median is the value that separates the upper half of the data from the lower half of the data. The mode is a number that appears the most often, and the standard deviation is a representation for the amount of variability within a given data set. We can easily calculate those values in Excel using some built-in functions, and we can also do the same in MATLAB. Okay, MATLAB is really great for data analysis, as is Excel. The only thing I don't like about Excel, and you probably already know this, in order to get the mean, you actually have to type out average, not AVE, not AVG, not mean. No, you have to actually write out the entire word average. That is one of my complaints about using Excel. All right, so histograms are also commonly used in descriptive statistics to represent a frequency distribution. Okay, what is a frequency distribution? Well, it's a type of bar chart where each bar groups numbers into a certain range. So for example, in this histogram, we have the heights of black cherry trees. On the x-axis, we have different ranges, so 60 to 65, 65 to 70, 70 to 75, etc. Those are values in feet. And then on the y-axis, we see our frequency. So let's say I want to know how many black cherry trees are between 80 and 85 feet. Well, I could come to this histogram and see this bar here, which is associated with roughly a value of 5. So that would tell me that there are 5 cherry trees between 80 and 85 feet. Excuse my bad handwriting. All right, let's look at another example, and this is actually an example we're going to work through together in the tutorials that will follow. But we have a histogram related to distance. And in this example, 15 darts were thrown from an automatic dart launching machine, and distances were taken from the target to see how off the straight distance was for each of the darts. Let's think now about how data distribution can look. Okay, so there are many cases where the data tends to be around a central value. In this case, it'd be right around here, okay, where there is no bias left or right. Okay, so you see that this distribution is the same on the right as it is on the left, so it is symmetrical. Another way to name this type of distribution is as a bell curve. Many things, many things, closely follow a normal distribution. For example, if I were to actually collect the data for everyone in EGR 103 height, it would follow a normal distribution. The size of things produced by machines, errors in measurements, blood pressure, grades on a test, all of those follow a normal distribution. However, there are cases where data can be spread out more on the left or more on the right, or in some cases, the data can be all jumbled up. So these are all ways that you may find your data in the future distributed. So let's move now to an online tutorial. There are a few things I need you to do. I want you to download the file called Target Data. Make sure to get the Excel add-in called the Analysis Tool Pack. So you'll need to have Excel open and work through the example with me, or you can just watch me work through it. But when you go to work on your own, you will need the Excel add-in. You can find the Excel spreadsheet and instructions for getting the add-in on our Getting Started page for Week 11's module. Also, in the first video tutorial, I quickly go over how you can get the add-in on a PC. So if you have a Mac, just Google how you can get the analysis tool pack. I think it's a little bit different. Watch the 2 videos called Using Excel to Make Histograms, and then you will do an assignment on your own. So just to give you a preview, in the tutorial videos, I will show you how to make a histogram using the data here called straight distance. And there are 2 other columns of data, horizontal distance and vertical distance. And what I want you to do is to choose one of those sets of data, not both. You just need to choose one of them and make your own histogram. So at the bottom of the spreadsheet that you open up, there are 2 tabs, one for option 1 horizontal data and one for option 2 vertical data. And there's a template on each of those sheets to get you started to create your own histogram. But please watch the online tutorials before you attempt to make your histogram so you can see exactly how it should be formatted. All right, I'll see you soon.